Hello friends, in this video we are going to study the new concept in boundary layer, that is wake and its formation. So let's start with the video. We are going to study the topic wake and its formation. This wake and wake formation occurs around a curved surface when exposed to the fluid flow. Say for example, this is the surface of either sphere or any other curved body, that may be the part of aeroplane or any other object. So in this case, when fluid flows around, say for example this is the flow of fluid, this is the direction, this direction indicates formation of boundary layer around this surface. If we talk about the ratio du upon dx, change in velocity of layer with respect to distances, here the x is along the boundary, so I will draw a reference x as this. This x is traveling around the boundary, so change in velocity with respect to x is greater than 0. It means that this rate is more or positive. And if I talk about drag force or pressure, then in that case this drag force dp by dx, change in pressure with respect to distance x, is less than 0. So less pressure is acting. So there are various points. I will define that points as point 1, point 2, point 3, point 4 likewise. This curved path, these curves are nothing but the velocity distributions at that respective points. We all know that in laminar zone we get parabolic curve. So if I join the points of values equal to u, then I will have the nature of boundary layer as shown in figure. So this is the boundary layer, which is formed along the surface. If I talk about boundary layer thickness, it is increased at point 2 when compared with at point 1. So this is the boundary layer thickness delta. This is increased over this region like this. So it is clear that if we are directing the fluid flow in a particular direction, then it will not continuously in contact with the curved surface. So it is clear that it is going to separate from the actual rigid body surface at a particular point. In this diagram, this third point, point 3, is the point where actual fluid flow gets separated from the boundary of the object, that is this rigid surface. So we will call this third point as a point of separation. At point of separation, it is clear that it is separated because no drag forces are acting at that point, or they are 0. So it is clear that whatever will be the pressure obtained will be minimum value, having minimum value. So if I talk about the distribution of pressure, it is reduced up to third point in this manner as shown in figure, highlighted in figure. So it is reduced up to P mean at third location, and as this is continuously reducing, we will call it as favorable pressure gradient. If I talk about next point, that is fourth point, then I will come to know that here the fluid has been separated and there exists a gap between actual boundary of fluid and rigid boundary of the surface like this. So this portion allows the entry of other waves like these, which are shown curvy waves. So these are called wake. So technically, if I want to define wake, then wake is region of velocity defect that that grows due to diffusion. So this is the region, this part, hatched part is the region where the wakes are formed. If I want to talk about velocities, then we will have the same nature, that is parabolic one at all the points, but starting from the actual start of the boundary like this. If I talk about region in the wake, then I will have negative nature. So this is the highlighted portion. This highlighted portion indicates negative. Hence, this du upon dx ratio becomes less than 0 because it is negative. And now I will have another relation as dp by dx greater than 0. It means pressure is now increased as compared to the third point. So if I continue with the curve of pressure distribution, I will have this increase which is highlighted in the figure. This highlighted increase indicates there exist higher pressure zones. Actually speaking, when we talk about drag, there are total two concepts. One is drag and another one is lift. So here is the presence of that another force, that is lift, that is negative pressure. So there exists presence of positive and negative pressures when I talk about upstream and downstream side. So technically speaking, I can denote as wake formation as a wake is developed on downstream of body, due to which pressure on downstream falls considerably and produces pressure difference on upstream and downstream. Wake is a region of recirculation of flow immediately behind a moving or stationary blunt body caused due to viscosity of fluid. So this is the region. This point of separation is the starting point of formation of wake. Hence, high drag force is needed when wake forms around a body. Now let us discuss the various effects on boundary layer. So effect of pressure gradient, we can consider a equation del square y upon del x square at y equal to 0 is equal to 1 upon mu dp by dx. So depending on curvature, total 3 cases are possible. Out of which first case is gradual increase in velocity and drop in pressure this case occurs between point 1 and 2. This is point 1, this is point 2, this is point 3, and this is point 4. So between 1 and 2 there is a reduction in the pressure which is gradual one. So in this case what actually happens, the result is entire boundary layer move forward until pressure gradient becomes negative. Second case is flow retardation occur and pressure is increased from section 2, from point 2. So in diagram this is point 2. So from point 2 there is a flow retardation and increase in the pressure. At a particular stage if it is continuously occurs, then at particular stage situation arises that momentum of fluid is unable to overcome surface resistance. So it occurs at point 3 where du upon dy that is equal to 0. So this point is called as point of separation. So this is called as point of separation, and boundary layer is on the verge of separation. Third stage is continuous retardation from surface due to retardation. Opposite flow occurs. That is, at this point, this fourth point, opposite flow is occurring due to entry of other fluid particles. These curves are formed. So we will have dp by dx greater than 0. So it is very important to study the location of point of separation. So let us see, point of separation occur, point of separation is located first case if du upon dy at y equal to 0 is positive attached flow. Secondly, du upon dy at y equal to 0 is 0, that is verge of separation, flow is on the verge of separation. This is nothing but the point 1. This is nothing but the point 3. And this is third case, that is du upon dy at y equal to 0 is negative separated flow. That's all. Thank you.